Hey everyone, welcome back. Today, we're diving into a few fun Arduino activities that show how simple components can come together to make some pretty cool interactive projects. Let's get started. First up, Activity 5, the mood cue. You'll need an Arduino Uno, a breadboard, a servo motor, a potentiometer, a 100F capacitor, 3 mil header pins, jumper wires, and a USB cable. To begin the mood cue activity, start by supplying power to your breadboard. Connect the Arduino's 5 volts pin to the positive rail and the GND pin to the negative rail so that both the potentiometer and the servo can receive power. Place the potentiometer on the breadboard with its 3 legs on separate rows. Connect one outer leg to 5 volts and the other outer leg to GND. The middle leg, called the wiper, should be connected to analog input AO on the Arduino. This allows the Arduino to read the changing voltage from the potentiometer as you turn the knob, which will later control the movement of the servo. Next, prepare the servo motor for use. If your servo cable doesn't plug directly into the breadboard, attach 3 mil header pins to make the connection easier. Once that's done, connect the servo's red wire to 5 volts, the brown or black wire to GND, and the orange or white wire to digital pin 9 on the Arduino. A helpful addition for this activity is placing a 100F capacitor between the 5 volts and GND rails near the servo connection. After completing your wiring, take a moment to review all connections to ensure everything is securely placed in the correct rows. With the hardware set, upload the mood cue code to your Arduino. The program reads the potentiometer value, maps it to a servo angle, and moves the servo arm accordingly. Open the serial monitor to observe the changing values as you turn the knob. You should see the servo rotate smoothly across its range, reflecting the position of the potentiometer. Once the servo is moving correctly, turn the potentiometer and watch the servo shift to different positions, similar to a dial. You can customize the code to change the servo's movement range or reverse its direction by adjusting the map values. For Activity 6, the Light Theremin. You'll need an Arduino Uno, a breadboard, a piezo speaker, a photoresistor, a 10,000 ohms resistor, jumper wires, and a USB cable. To begin the Light Theremin activity, start by powering your breadboard. Connect the Arduino's 5 volts pin to the positive rail and the GND pin to the negative rail so your components share the same power source. Place the photoresistor on the breadboard, making sure its 2 legs sit on separate rows. Connect one leg to 5 volts, then connect the other leg to analog input AO. From that same AO row, add a 10,000 ohms resistor to the ground rail. This forms a voltage divider, which lets the Arduino read changing light levels as you move your hand over the sensor. Next, add the piezo speaker to the breadboard. Place it so that its 2 pins are in different rows. Connect one pin to the ground rail and the other pin to digital pin 8 on the Arduino. The piezo will act as the output device that produces sound before moving on. Take a moment to check each connection. The photoresistor and resistor should share the AO row, one side leading to 5 volts and the other to GND. The piezo should be wired so the Arduino can send it audio signals without any loose or crossed wire. With the wiring done, upload the Light Theremin code to your Arduino. The program reads the analog values from the photoresistor and turns those readings into different sound frequencies that play through the piezo. Open the serial monitor to watch the light values change in real time. As you move your hand closer to or farther from the sensor, the amount of light it receives will change, and you'll hear the pitch go higher or lower.